Morning, everyone, and thanks, Drew. It's been an interesting ride through the last 30-odd years of this industry, hasn't it? And I think we're at a very, very exciting inflection point. So I want to talk a little bit about really picking up on some of the themes from the earlier talks this morning as to how we can actually respond to that. But first I wanted to pick up on just one or 2 points. Firstly, the Internet of Things is not just about billions and billions of little sensors all talking to the cloud. There is so much more to it than that. And I'll talk a little bit about that later on, but do remember the IoT, in the world of marketing, and most of my career is running chip design teams, not running marketing. And so it just appalls me the way IoT is reported. I've got figures, we just did some analysis the other week of 20 billion, 30 billion, 50 billion units. You choose your number because they're all irrelevant. It's a matter of what's actually going to ship that wouldn't otherwise ship. What's new is what matters in IoT. And IoT is not just about sensors, but it's about dumb sensors, but it's about highly intelligent sensors. It's about how that data is processed in the cloud and what is increasingly known as the fog, all of that computation and connectivity that sits between the sensors. These are opportunities for innovation, and it's a huge area, and I think the skills here in Europe are ideally suited to that world. So I do hope that Europe will respond to that as part of that. The other thing, just to clarify, Gabrielle was talking earlier this morning about Imagination's history. There is in fact one extra one to add, and we acquired a small RF company recently as well, and I'll point a little bit as to why later on in my talk. But the thing about MIPS is it was quite disruptive for Imagination. But more importantly, MIPS history, in fact, comes from performance. MIPS has been around for more than 30 years. It's been 64-bit for more than 20. And in fact, its history is in performance. It came to the embedded world and is used a lot in embedded, particularly for things like multi-threading, over the last decade or so. But it's quite interesting when you look at its history compared to ARMs and Intels and other processors in this space of the breadth that MIPS has. So be rest assured you'll be hearing a lot more from us about MIPS coming forward from the low end to the very high end. But let me focus now on my talk this morning, which is about platforms. And this really draws on the earlier talks about how you actually get innovation to enable companies to build stuff. If you look at Imagination, as with any IP company, we have to do more than just understand the IP we develop, whether at large or small, specialized or mainstream. It's all about understanding where that IP fits and how it brings value add to the applications that result. So from Imagination's point of view, we're particularly focused on these new emerging areas. I will try my best not to use the term IoT because it doesn't mean anything. Things like wearables, things like ADAS for automotive, things like the smart home and the connectivity within the home, e-health. These are things where you can start to relate IP to these applications, and it is vital that we talk in these terms if we're going to translate this into any sort of meaningful business. So something I think people in this room will understand very well is it takes a long time to get from IP to a volume shipping product. Something I think the earlier speakers were highlighting is the financial community rarely understands this, and indeed this is a foil from a slide from something I presented to the financial community in London just a few weeks ago. It takes anything 5 to 7 years from when we're completing the design of IP to when it actually goes into a semi, to when that chip is taped out, to when that chip is designed into a product, and that product hits volume. Only then do we see the volume returns on a design, and it takes 5 to 7 years in practice. Those timescales are coming down a little bit, but the complexity is going up and the breadth is going up. And so this is what is fueling the IP business. And so if we look at the role of IP, this growth in integration means more systems on chip. Our whole business at Imagination is focused on the fact that to get to volume, it needs to be single chip. It doesn't matter what it is. It doesn't matter whether it's a small integrated sensor or a mobile applications processor or a data center blade processor. It will go to an SoC for issues of performance, of power, of cost, and scalability. So the IP model works as more and more things become built on SoCs because they bring, an SoC by its very definition brings so many different areas of expertise together. An IP becomes from an option to a fundamental. The consequences of these SoCs is the system complexity of these designs is increasing all the time. So the application domain knowledge is absolutely essential, and that's where the startups that are fueling this next point, this inflection point that Gabrielle was referring to, is very fundamental, and we're right at the start of it now. This will come from application domain knowledge complemented by technology understanding. So we think that that starts by having building blocks of scalable, proven IP, because that de-risks those building blocks that are necessary to enable the platform. And indeed, what I'll talk about later on is customizable IP platforms of how you join those things together, and then bringing that with the application know-how of the partners that we license our technology to, because the key in all of this is differentiation. If you do not have differentiation, you will be in a pricing war. It's as simple as that. You either have value added or you're trying to undercut the opposition. When you have undercutting, no matter how big a scale you are, sooner or later that will bring your business to its knees. So differentiation is fundamental. And this is something I think that Europe and the US are particularly strong at in terms of understanding this differentiation point. And that's why we're in such a global business that the marriage of the world of IP with the world of who is actually making these things in volume, and really understanding that is fundamental to business success. So the key thing here is customers of all of us, large or small, is about enabling our customers to invent only what they need to invent because they're best at it. And we need to provide all of the other parts so that they can focus that. The more they can focus what engineering resources and business resources they have, that will enable them to get a lower risk design to volume faster and cheaper, and therefore more competitively. So from our point of view, we build our IP platforms on three basic pillars: multimedia, processors, and communications. They're pretty fundamental. Multimedia is anything to do with pixels in or out, fundamentally, and audio also sits in there. Processors, we all know the CPUs running software, though increasingly GPU compute is software running on parallel processors, which I think, again, for those of us in Europe, most of us have touched parallel processors at various points in our career. It's very nice. It is going mainstream now, thank God. And communications. And communications is a fundamental driver of this next inflection point. Everything will be connected. That's the significance of IoT. There is no point in designing any product, large or small, specialized or mainstream, that is not connected. So those, for us, are the three fundamental pillars for any SoC. And so we're working to build platforms around that so that people can then add their components as easily as possible. Because what we need to do is to create the environment so a company can, as efficiently as possible, with whatever funding they can get, with whatever knowledge, be it in software, hardware, systems, whatever, can bring that application know-how to create the solution, building on that platform, and from that you create the solutions. Solutions are what sell. Ultimately, a chip doesn't sell. It only sells to the manufacturer. If the manufacturer doesn't sell an end product that does a job that provides value, nobody wins. And so we, in this next phase, IoT is about taking technology to the next ubiquitous point of everything having a much more higher level of sophistication. We can all benefit hugely from that, but we must be thinking more about that whole supply chain, from the underlying IP that we create through to those end solutions, and how we play our part in helping our customer differentiate. This is something we put together because when we look at the IP business, if you look at the rankings, we'll know ARM is number 1, we're number 3, Synopsys is number 2, Cadence is now number 4. And those 4 companies we feel will continue to be a strong leadership behind that. And beyond that, then you have the strong rump of specialist IP providers that drive the bulk of our industry. But if you look at it in terms of the main processes from our point of view, we're doing the big complex blocks. CPU IP is the most mature of those. It's been going for about 30 years now. And the lighter curve is that going back about 20 years, that had already started. in terms of people starting to realize designing CPUs in-house was not a value add. And so the IP business started in terms of these larger blocks as opposed to specialized stuff, and obviously companies like ARM led the charge on that. And we believe in terms of the grand scheme of things, if you look at all of the chips that are being designed, then we see that by 2019, 2020, about 80% of all chips that are shipped that have a processor in them will use IP. It's not 100%, and it's not 90%, because there are still a variety of ways where people use dedicated processors for their own means. And you can debate that figure, but it's important. The thing is that the CPU point has crossed over where these days the idea of somebody designing a new CPU in-house is a brave decision. That's still happening, but it tends to be for niche. Multimedia, which what we're best known for, is relative to that earlier in the curve. We think ultimately it will be more like 70% rather than 80% by 2020, simply because you then look at a number of chipset guys in this space. They are morphing their businesses into things that are using their in-house IP. These are the NVIDIAs, and you include people like Qualcomm with Adreno, which is an in-house GPU for them. And so that's where we see that happening. Also, you see video, which a lot of companies developed in-house, as that continues to say, what is the value add of having that as an enabling technology in-house? What's differentiating you? Is another fuel for growth. So this is graphics and video, as well as cameras and all of the multimedia blocks. And then the exciting one for us is the communications IP, what we call the RPU, the radio processor unit. And we think this is a huge and fundamental factor in the growth of these connected applications. And it's barely started. We've had more than a tripling of licensees in our Wi-Fi, Bluetooth and broadcast technology engines over the last year. So the growth is starting to show sign, but it's early days. Let's also remember, outside the big application platform chipset guys, the main IDMs like Intel and AMD and Qualcomm, people like that, you look at the next big chunk, and they're comms chipsets. But the trend is unstoppable towards integrating communications on chip. So either you've got it in-house, or you're going to need IP, because developing this stuff, like any of these big blocks, is extremely difficult. And of course, that's not only digital, but it's also analog, because communications, more than these others, talks to the real world. So there's a lot of life we see in the next 5 to 10 years. We ultimately think that RPUs, communications IP base, will be about 50% of the business, because what you're going to see is a lot of very well-established and very substantial companies whose business is built entirely on communications chipsets will be morphing their businesses, as it's not enough to do just communications. But there will be tremendous opportunities for all of us in that space. So let's have a look at what is actually driving platforms and how to help our customers. Well, we see 4 forces: differentiation, time to revenue, the design cost, and design time. So let's have a quick look at each of those. In differentiation, the holy grail is to be differentiated and to get as much value for that as possible. And there are a number of applications. Certainly for us, a number of years, graphics has been very good for us in that area. If you go back many years ago, the CPU was very good for a number of companies. And each of us in the IP space can find those niches where the value exists to be able to help us to differentiate and grow our market. But the danger is to be seduced too much into the volume, because in an IP model, if you don't get your business model right, you may have great volumes, but you may not have a sustainable business to support those volumes. Volume doesn't come for free. Once you've shipped your IP, you need to support it. And you need to evolve it and keep on the edge. Because if it's high volume, other people will want a part of that business. And so striking that balance and differentiation is crucial to success in the IP business. The next thing is time to volume. This is crucial, and this for us drives the success of the IP business model, which we think is unstoppable now in terms of its growth, to make things cost effective. If you miss that market window, you will be forced onto the back end of that curve, and that means that you will be forced into a much more competitive environment. So striking that balance of being too early, being too late, is the trick of deciding where your IP and where your innovation lies and getting that time right. But we must take into account the Asian dynamics, which are much, much more about early time to volume. And there's a lot that Western companies can learn about the speed with which our Chinese colleagues get things to volume and how they exploit things like in-field updates of software, doing revisions to a chip that is pin compatible but solves those little gremlins we all know exist. And the ways that they deal with that in order to have a successful product. We have a lot to learn from the way they manage that rather than a more sequential pattern that we will tend to do. So this accelerating that to us is fundamental when taking this global paradigm into account. The one that's really interesting, I'm sure there'll be a lot more discussion over the next 2 days, is about the cost of design. We all know that we're going down these nodes as we go down through 28 and 20 and 16, 14 and 10 and beyond. If you look at that end of the curve, yes, it gets harder and harder to close these things out, huge levels of complexity. But as I'm sure you're going to hear more about in the next 2 days, we don't see IoT as just being on the bleeding edge of process. We see a lot of this happening at the 55 and 40 nanometer nodes and beyond way back to 130. Because it's all the analog, it's the flash, it's all this power, all of these factors need to be integrated into the SoC to make successful connected devices that are going to be in embedded environments. And so this is not just about driving that down to 10 nanometer, and we're heavily involved in that. But it's also going to be an increased and much longer life to these more established nodes because of the design flows and what needs to be done. But the complexity is going up because the level of integration needs to be much higher than what those devices at those nodes traditionally did. But what that graph is showing you is that as we look at the relative components of the driving cost of design, the big ones there are now in verification and in software. And this is something that as a hardware-centric industry in terms of semiconductor IP, we struggle with. We can say the words on software, but we have a lot to learn. The mobile industry has really taught us how to hit that head on, because you have to get a mobile product working right. IoT will take it to a whole other level. The software has to work just as much as the hardware. But verifying these designs when you're going to high volume is the big sting in the tail. It's getting harder and harder. And so a huge amount of our work and working with our key ecosystem partners is all about how to bring that verification down. And we think IP platforms is a way to do that. So if we look at this SoC design time, if you look at all of these steps, you then start digging in with these integrated systems and you suddenly see the times are going out, certainly at the leading edge of stuff, but the market won't let you. And so we do have a fundamental crunch. And that's why you have to do more about deriving from existing designs to get these things out. And so our fundamental argument is that by using IP intelligently to enable a customer to focus on the minimum amount of engineering to differentiate their product uniquely is the fundamental difference. We have to break this barrier that if I'm engineering an SoC, I fundamentally design it all in-house. And the difference is dramatic. The timescales and the costs are a dramatic difference. And this is based on our understanding of working with most of the tier ones in this industry. This is not just, this is actually from an in-house analysis we did of the data we know of how much it costs the tier ones to develop. And so for a tier one, they can manage it because of the value add that it brings to them. But for fewer and fewer people, does that make sense? And that's why the IP model for us is just entering its momentum phase now, because much more of the IP of the SoC will be built on IP. So I think you all understand what an IP product is. IP is about. What we're looking at is reference IP platforms, because now you've got to start joining these things together for the different applications. And so it's all about creating sockets for our customers to be able to bring in their IP, other partners in IP bringing their specialist IP to complement our own, and finding these ways of creating these frameworks and as much as possible pre-verified IP reference platforms, so that the time to volume using these differentiated IP is minimized. And it's got to talk with the software as well. So as you see, for example, a move to connectivity, then you've got a dramatic move towards 32-bit processors and beyond, because communications demands significant address space. You find many, many more devices running a high-level operating system like Linux or Android in order to do some of even these more deeply embedded applications. Having said that, I think you're going to see a great resurgence back to RTOSs. But they're going to be RTOSs enriched with some of the application frameworks you see from today's Android and Firefox and other application platforms. But it's all at the end of the day to getting a product out. So the differentiation also, and another thing for the IP industry to embrace, is it's not just hardware. The differentiation in the software stack is every bit as important. And this indeed is where we see a lot of value add. Now remember, what we're trying to do here is to create the new players. Every 5 to 7 years, this industry changes. 7 years ago, it was the mobile and era of the mobile and tablet. That industry is a great, maturing, strong machine and is going forward. Just like PCs are not dying, they're dwindling a little bit, but they'll take a long time, that long tail. But it's how we create the new players, and that's the opportunities for all of us. And so that's embracing what you need to get to an application in the software. And it isn't just the software. It's all the layers from the very low level in drivers and so on through to the operating system and optimizing the operating system, configuring it to suit the platform, the drivers that need to run with that operating system, and then the middleware up to the applications. And it's a mix of our customer that's got the differentiation understanding, ourselves as a primary IP provider, and the ecosystem that will provide hardware and software to be able to do it. So this is how the ecosystem has to work. This is how the IP community has to get together. It's not just about hardware IP. It's tying it with that software and how we do that. The mobile industry, again, has taught us quite a lot about how to do it. But it's a matter of how we execute that in this next wave. And I think this will be particularly crucial in IoT. So our IP portfolio is actually looking like this. We're best known for GPUs. That means not only graphics, but also GPU compute. People don't realize we've shipped over 1 billion video decoders and encoders. So we regard ourselves as number one in that space. You'll see a new area for us, vision. We've got a complete camera ISP family of IP now. So anything about pixels coming in and out of the chip. We've got MIPS. MIPS goes from deeply embedded, ultra small processors all the way up to heavy-duty, multi-cluster, multi-core networks of 64-bit processors and everything in between. So believe you me, we are taking on the spectrum from the low to the high and everything that space embraces. But then we've got our Ensigma communications, where we think we have a dramatic lead in terms of the Wi-Fi, Bluetooth, TV, radio markets, all within the same engine. And we've got various other things coming around the edges of these as we build these IP platforms. And that has to be bound together with SoC fabrics. Fabric is going to become a more important point because that actually provides the framework for binding our IP together. And indeed, something that is interesting, indeed, John and I were talking about last night, was how we actually need to revisit the area of standards to make it easier to connect these different building blocks in these sorts of designs. This is not just a fabric-driven SoC is no longer just about high-end processors and therefore not relevant to many of us. In the embedded space, this will be more and more important because this is the way we bring the different IP blocks together on a single chip. Analog, digital, specialized processing, dedicated hardware will come together in small devices as well as big, and particularly smart sensors to make that happen. So that's our portfolio, and what we find is because we need to embrace the software side, we provide all the drivers and operating system ports and so on needed for our IP to do what we do, and that's all in-house because we find more of our support for our IP is on the software than on the hardware. But beyond that, we know for IoT, you've got to have an infrastructure to connect to, and so much of that is driven by the IT world, they actually don't understand embedded very well, and I think that's a huge opportunity for us all, is to be able to embrace that internet connectivity. And so we've got our own offering there, but we work with many others, and there's a lot more that we do. It's all about being able to enable more startups that have got a great idea, know how to get a product, know what the differentiator is. What can we do to provide across our ecosystem to enable those people to get to volume. Those are the new players, and we shall see a bunch of new names that 5 years from now will be completely different that are not on our radar today. We need to enable those. So some of the examples, the platforms we're putting together look like this. I mean, from IoT, the basis of that is what we call a connected processor, which means you're a deeply embedded processor, probably running an RTOS, plus connectivity. And so we have a very specialized ultra-low power connectivity, does low power Wi-Fi, does Bluetooth Smart, very sensitive interfaces like 6LoWPAN and so on. But you can scale that communications up because that also needs to talk to higher performance networks. We go up, connected audio. Audio is in a lot of things that we do, so we've got doing quite a lot there, through to our mainstream connected AV. Think of that as really a classic mobile application processor, through to the high-end computer application platforms, as we see more and more real-time being able to deliver the value added by the algorithms running on a mixture of CPUs and GPUs. And we see a huge interest in GPU compute for this, for example, in real-time processing, which means it must be local. My personal bet is smart cameras are a huge area in this, and tremendous innovation for algorithm development and systems design, as well as in the IP itself. All the way up to very high performance AP. We actually think at the high end, blade computing is going to change, and it'll change to heterogeneous processing. It is not just going to keep going of the big iron route we've seen for the last 30 years of how many CPUs you put in there, because what we've learned from mobile is use more specialized IP, GPUs, video processors, comms processors. The more you do that and understand what's running in the data center, the more differentiation you have. And if you can save 50%, 80% of the power consumption to get the job done, that is enough to create the disruptive force. We think that's a major disruptive force, and we're doing quite a lot to make that happen. We're already working with a number of partners in this, and these partners are not names that you know. And that's what's exciting about this. By looking at this platform model, new customers are out there, and that is very, very important for our industry. We're working on platforms. This is an example of an IP platform where you can put multi-cluster, multi-core CPUs alongside multi-core GPUs, and then, of course, being able to do some of our network processing on there. But by getting those core building blocks together, then people can be looking at specialized offload processors to sit alongside it. It's where that customer differentiation comes in, which makes the difference on these platforms. If you go to the other extreme, the most basic IoT controller will be a small MCU. It will be 32-bit because running a TCP IP stack on less than that is hard work. Alongside the communications, the analog will have to be on chip, and that's, by the way, why we brought RF capability in-house, not because it's shrink-wrapped RF. Anybody that's done that, and I certainly have run a couple of teams on that, know it is anything but shrink-wrap. But we need to help these customers to get these things to volume. And so the network of analog skills we all know are widespread and specialized. These are going to add value in this world as we go forward, because all of IoT has to talk to the real world. And so that's the domain of analog. So there's going to be a lot happening there. These small but smart sensors are because they can't just gather data and send it up to the cloud. That won't work. So these have to be triggering only on events to minimize the traffic into the network. You can't have billions of devices unless they're more intelligent than just gathering a sensor, and that's where a lot of innovation can happen. So just to wrap up, the key thing about the IP business, if we do our job right, and it's a community, this is not just imagination, this is us all working together. The IP model correctly executed enables us to enable both existing customers from the tier 1, tier 2s to the new startups to invent only what they need to invent, be it hardware, software systems, whatever, to be successful. And that's our job, is to enable as many of those as possible. That is what will take us to the next level in the IP industry. Tier 1s will continue to select the best IP in isolation. That's what they do best. That will not go away. We love them for that because that's what drives the leadership. And we're fortunate to be engaging with many of the tier 1s in our industry today. But for the smaller players and the newer players, this platform approach to IP is absolutely fundamental, in our opinion, to being able to de-risk, to collapse that verification cost, to be able to collapse that software cost by having as much as possible pre-verified from which you derive the production device that is absolutely optimized for the differentiator. And that's what we think is the fundamental. And that's why the next phase of this industry is all about IP platforms we think it'll do all the things needed to be able to enable these next wave of players. Okay, with that, thank you very much.